Um, Welcome all back to the observability and security track, the last session for today. And now we've got Kim alongside to tell us how we can bring OWASP security testing coverage to our builds automatically. Those of you that might have been in the last session will have noticed there was an awful lot of commentary there about red teaming and the whole kind of red team integration. I love that in the naming for this, Kim, you've blended the two typical participants in the security testing exercise. So it's not the red team versus the blue team, it's both working together. That's very neat. So yeah, I'll hand over to you, Kim, and please give us your overview. Thank you.
Cool. Cheers. So I'll just I'll share my screen now and get stuck into it. So hi everyone, I'm Kim Carter, also known as Binary Mist. I was born and bred in New Zealand, and I'm the founder of PurpleTeam Labs. I've written a collection of books. These are all on my website, binarymist.io/publications. These three here that look quite similar are Holistic InfoSec for web developers. They can be purchased or they can be read online freely. And the Cloud Security and Docker Security books came out of the Holistic InfoSec for web developers series. They're quite a bit smaller, but they're basically just taking a little bit of content out of these other three. Okay, so these are some of my podcasts that I've been interviewed on and hosted. Again, these are at my website, binarymist.io/publications. And my blog, which has got well over 100 posts in there on all sorts of technical topics and agile methodologies and all sorts of good stuff, I guess. So I'm the ex-OWASP New Zealand leader of 8 years for Christchurch. And I'm going to be walking you through PurpleTeam, the open source security regression testing CLI and SaaS for web applications and APIs, along with how you can go about inserting the PurpleTeam CLI into your CI and nightly build pipelines to find and fix security defects that developers are introducing daily. We're discussing how the different microservices communicate with each other, how to debug them, and how you can set them all up to get your web applications and APIs under continuous test. So PurpleTeam is a security regression testing CLI. That's the front end, and a SaaS, software as a service, back end, targeting web applications and APIs, specifically built for developers. The CLI is specifically targeted at sitting within your build pipelines. It can be run headless, but can also be run manually with a character user interface. You can choose from either local and or cloud environments. If you go with local, you need to set up both the front-end CLI and back-end microservices. If you choose cloud, then all you need to do is get the CLI set up on your system that you want to run it from, configure it, and create a job file, and then you're ready to go. So it's been approximately a 4-year journey that has brought PurpleTeam from a proof of concept to where it is now. So I finished writing a long book series. That's the Holistic InfoSec for web developers that I just showed you, to help developers upskill their security. And again, that's free to read online. And I held lots of workshops with the proof of concept all around the world to elicit developer feedback and confirm that what I wrote about was actually true and was going to fly. Most of the time it's been like 7 days a week and 2 full-time jobs. I donated PurpleTeam Local to OWASP in Q1 of 2021, and PurpleTeam Cloud went to market in Q4 of 2021. I couldn't get the publicity that was needed to get enough customers on board to make cloud financially viable. Plus, family relationships were getting strained. So I'm in the process of donating cloud to OWASP currently. So now the community gets to reap the benefit of a production-ready hosted security regression testing SaaS that you can plug into your build pipelines to continuously test your web apps and APIs. So it's by the sound of it, it's going to become a member benefit. So if you're an OWASP member, then you get access to PurpleTeam Cloud as well. Now, building a tool that helps developers write secure code is a great way to learn about security. If you want to learn more about information security, we can assign a mentor to you, and you can help yourself and the community by helping us build PurpleTeam. So I'm just going to do a quick walkthrough of the architecture. So this is the cloud architecture, and this is the local architecture. So as you can see, most of the components in the cloud architecture are in AWS. The only thing that's not, I think, is from memory is DNS. So what we've got in the local is we've got a CLI here, and then we've got the back end here. So the orchestrator takes the job file from the CLI. So in the job file, I'm going to be walking through how to build a job file later on. And the job file has test sessions. Now you can have 1 to 12 test sessions. Each of those test sessions refers to routes, and you can also have, there's 2 different types of job files. There's one that tests browser applications and one that tests APIs. Now when the CLI sends the job file through to the orchestrator is responsible for communicating with the testers and receiving real-time events from the testers that it sends back to the CLI. Now what we've got is 3 testers currently. We've got the application scanner, the server scanner, and the TLS scanner. The server scanner is stubbed out. It's not actually, most of it's not implemented. Now the application scanner is responsible for a set of emissaries. Currently we're using Zap and Selenium. Now these are external emissaries, so they're sitting out in their own container set. And for the TLS scanner, we've got testssl.sh, and this is an embedded emissary, so it actually sits within the same container. Now, when the job file comes through to the orchestrator, say for example, it's got 2 test sessions in there. So what's going to happen here is the orchestrator will, it's the orchestrator? No, it's actually the app scanner. The app scanner actually spins up 2 sets of its emissaries. So there'll be 2 Zaps and 2 Seleniums. This provides good isolation between the different test sessions as well. And as the test run's progressing, the testers send progress updates, percentages complete, back to the orchestrator via Redis channels. Now, if the CLI is using, so there's a couple of options that the CLI can communicate with the orchestrator with, either server sent events or long polling. In the cloud, it's only long polling due to some API gateway limitations, but locally you can use either or. And there are some pros and cons to that, and that's discussed in the README file of the CLI. Now, if you're using server sent events, once you've basically registered your interest with the orchestrator pushes those tester updates straight back to the CLI without the CLI having to ask for them again and again. If you're using long polling, as a long poll request comes from the CLI into the orchestrator, actually I'll come at it from the other way. The events that comes from the testers into Redis channels, and then the orchestrator pulls those events off the Redis channel, each Redis channel, and puts them into lists. And then as the long poll request comes into the orchestrator pops those events off each of those Redis lists, and then responds to the CLI with them. So essentially the CLI sees what's happening in the back end real time. You'll see this all in action soon. Locally, we use Docker Compose to host the stage 2 containers. In the cloud, it's just ECS. In the cloud, we're using AWS Lambda to host our Lambda functions. Locally, we're using SAM CLI. Now, the testers basically talk to a Lambda function in order to spin up, it's just the application scanner, in order to spin up the stage 2 containers and to bring them down again. So, yeah, and you've got your system under test out here. It's your internet cloud, and your testers are testing your system under test. That's basically how it all hangs together. How does PurpleTeam help us as developers? How does PurpleTeam help us as a business that creates software? And why would I want PurpleTeam in my build pipelines? To answer these questions, I'm going to take you back to a section that's in a number of my previous talks. Traditionally, how have we found security bugs in the software we write? Basically, we haven't really, or we've just done it really late. So our red team has a week or two to find the defects we've been conscientiously adding for months. So this exercise is approximately $20,000 per week. For a small to medium web application or API, the engagement's generally going to be about 2 weeks. And the software project before it's released is about 6 months. So that's about $40,000 per 6 months per project. And generally 5 criticals, 10 highs, 10 mediums, 10 low severity bugs might be found. And many bugs are left unfound, waiting to be exploited. So the business decides to only fix the 5 criticals because they're now so expensive to find and fix. So each bug has got an average cost of 15 plus times what it would have cost if it was found and fixed as it was introduced. So that's 5 bugs times 15 times 320. That's basically a 2 developer hours, and you're coming out with a figure of 24,000. So the bottom line is, for a 6-month development project, that's a 2-week engagement. That's going to cost you $40,000, and only 5 red team bugs are going to be fixed at a cost of $24,000. So the bottom line here is it's too expensive, it's too late, and too many bugs are left unfixed because it's now so late in the SDLC, and each bug now has a cost of 15 times plus what it would have cost to find and fixed if it was found and fixed as they were introduced. So instead of deferring the finding and fixing of security defects to a traditional red teaming exercise, PurpleTeam helps us find and fix our defects as we're creating them. But how, you might ask? So PurpleTeam runs against our web apps and APIs as we're creating them, informing us of the security defects we're introducing in close to real time. PurpleTeam reports show us how to reproduce the attacks that found a given vulnerability, with tips on how not to introduce the same types of vulnerability again. There's also techniques for removing false positives or any defects you're not interested in seeing. So now we know we need PurpleTeam. Let's have a look at the setup. So we're going to have a look at the local setup to start with. So head to the setup page, and we're going to cover all of these topic, microservices. So to start with, you need to set up the Docker network. You can do this manually, or you can just basically run the orchestrator's compose file, which creates the network before it actually does anything else, so it'll create the network, and then you run it again, and it'll bring up your stage 1 containers. You're obviously going to need a system under test. For web applications, we use NodeGoat for a lot of our stuff. We've got an override file, a Docker Compose override file for NodeGoat that you can use as well. And if you want to test the same system under test in the cloud, then you can use PurpleTeam Infrastructure as Code SUP, which is just another project that allows you to Dockerize systems under test and deploy them using Terraform. And it's, yeah, super simple to use. So Lambda functions, the details on setting them up are on the README. There's a link to them there. Stage 2 containers, same sort of deal. Not much to it. Orchestrator. With the orchestrator, there's some environment variables to set up. There's a couple of directories to set up, and you've got to get your permissions correct with them. If you've got a firewall, then you're going to have to poke some holes in it so the different components can talk to each other. And you'll need to make sure host IP forwarding is turned on, and there's details there for that. For the testers, as I mentioned, the server scanner is not yet implemented, but the application scanner and the TLS scanner details for setting them up are here. It's not much to that either. For the PurpleTeam CLI, there's quite a bit more to do. Let's have a look at that. Yes, that's the contents here. We're going to come back to this soon. Okay, so for the cloud setup, just install the CLI and the rest is done for you. So let's have a look at the install options. So we've got 3 main install options there that we've basically used in anger. So it's clone the Git repository, npm install locally, and npm install globally. So cloning the Git repository is a good option if you're planning on running or debugging PurpleTeam standalone with a UI. The npm install locally option is a good option if you're planning on running or debugging PurpleTeam as a spawned Node.js subprocess, for example, from your Node.js build pipelines. And the npm install globally option is a good option if you're planning on running debugging PurpleTeam from a build pipeline written in some other language. And then you just need to configure the CLI. So with this, there's just a config file. You need to set up some values in here. There's examples in the actual files anyway, and plenty of documentation here, so you shouldn't have too much problems with it. This UI section is just for whether you want to run the CLI with no UI, so that's headless. So that's, for example, that'll be within your build pipelines, or if you want to run it with a UI, which you'll see shortly. So you would use that if you're running it manually. So for running the CLI, we take the same 3 options. It's these 3 options here, and we just bring them down here. So if you've cloned the Git repository, then this is how you will be running the CLI. If you've npm installed locally, then this is how you'll be running it. And same with the globally option. So not too much there, pretty straightforward. If you're using cloud, then job done. There's nothing else to do. If you're using local, then there's a bit more to know about running the back-end components. So we're just going to walk through 3 sections really quickly, just 3 sections of the docs. So there's some details around the AWS Lambda services. This is generally if you're planning on contributing to the project. You may need to use these commands, although in saying that, I haven't used them for probably a year and a half, 2 years, and was talking to someone yesterday on Slack that was having some problems with one of them. Turns out there's a new flag that's been introduced. So these, I forget which one it was. One of these anyway, just needs an extra flag, so we'll sort that out soon. Yeah, so your different lambdas here and how to basically run them and test them. Okay, so we've got a debugging section here. This will allow you, if you're contributing, to debug any part of the stack. The app scanner and sub-processors. So there can be multiple sub-processors in the application scanner. As I mentioned, this depends on how many test sessions are in the job file, and the steps there should be all you need for that. For the other testers, there's just a single sub-process, so it's quite a bit easier, but the steps are quite similar to this. With the orchestrator, there's no sub-process, so it's trivial. For the front end, we just use Chrome developer tools, and yeah, all the details you need are there. So for a full system run, which I'm going to be showing you next, these are the steps you'll be taking. Cool. So I'm just going to share my tab and turn the audio on so you can see what I'm about to show you. Oh, and also let me know if you can't hear the audio as well.
Hi, today I'm going to show you a test run with the backend components as well. I'm starting Docker stats to show you which containers are coming and going. We start Docker Compose UI, which is responsible for taking orders from our Lambda functions to start and stop the stage 2 containers. We start SAM local, which is responsible for hosting our Lambda functions locally. And we already have our system under test running. Now, once we've built our stage 1 images with npm run dc-build, we can bring them up with npm run dc-up. And then we start the CLI. In the bottom left terminal, you can see the validated, filtered, and sanitized job file contents. In the top right terminal, Docker stats is showing us the stage 2 containers being brought up. In the bottom left terminal, we're checking and retrying that the stage 2 containers have come up and are responsive. All testers are now running. As the test run progresses, in the CLI tester complete panel, that's the donut meters, you will see the percentages progress. These are total percentages per tester. In the running statistics panel, just to the right of the donut meters, each row represents a test session as defined in the job file. Here I'm tailing the CLI TLS tester log, just to save right arrowing on the CLI terminal to the TLS tester screen and not being able to also see the app tester progress. Back to the running statistics panel. The thresholds you see are also defined in the job file as alert thresholds. A given test session will be considered a fail if the bug count exceeds the alert threshold. Alert thresholds are useful for brownfields projects where you have existing defects but still want a test to pass. These are the definitions. You may find yourself referring to these quite often. Back to the running statistics panel. You'll notice a complete column. These cells represent percentage complete of the test session, where you may have more than one of these for a given tester. In order to initiate a test run, the build user needs to define and supply a job file. This is the documentation that will help explain the schema and help you construct your job file. Next, I'll show you some example job files. This job file is very similar to the one we're using for this test run, except we're targeting nodegoat.sut.purpleteam-labs.com, which is deployed using the PurpleTeam infrastructure as code system under test project. The new bugs panel of the CLI shows bugs over and above any specified alert thresholds. If this count is above 0, then you are going to have at least one failed test session. The total tester progress meter to the right of new bugs shows the combined progress of all testers. These logs I'm showing you are the raw CLI logs taken from the current finished test run. This particular log is from the low priv user test session of the current test run, currently being written to the top of the two CLI window panes as we speak. You'll notice that this particular test session is only testing a single route, the profile route of our system under test. This particular log is from the admin user test session of the current test run, currently being written to the bottom of the two CLI window panes as we speak. This test session is testing two of our system under test routes, the profile route followed by the memos route. As you can see, the server tester is currently inactive. Now we're looking at the TLS tester log. There's only ever one of these per test run. You'll notice the color codes in amongst the text. These are used to display the log text in color. We'll see how this works soon. We're looking at the same CLI logs as before. Tools such as cat, less, and tail, if configured correctly, will render the color codes. Just reiterating that these CLI logs are currently being written. I've just taken them from the finished test run. This is the low priv user test session CLI log from the application tester. As you can see, this is a failed test session. This is the one and only TLS scanner test session CLI log that I showed you before, but with the color codes rendered. These CLI logs are what is printed to the CLI terminal if you are running it in CUI mode versus no UI mode. Right arrowing and left arrowing in the CLI terminal will switch between the different tester windows. As you can see, this is a failed test session. When you see the outcomes have been downloaded to message, that means the test run is complete and you can now inspect the report files generated by the emissaries and the result files generated by Cucumber. This is what the outcomes archive looks like once it's been packed by the orchestrator and sent to the CLI. You'll notice the report and result files. This is the HTML report file generated by the application emissary, ZapProxy, for the low priv user app scanner test session. It lists the alerts or defects, along with how they were found, how you can reproduce them, as well as directions for fixing them. This is the HTML report file generated by the application emissary for the admin user app scanner test session. This is the HTML report file generated by the TLS emissary, test.ssl.sh, for the one and only TLS scanner test session. This is the Markdown report file generated by the application emissary for the low-priv user app scanner test session. This is the Markdown report file generated by the application emissary for the admin user app scanner test session. This is the CSV report file generated by the TLS emissary for the one and only TLS scanner test session. Here I'm highlighting the severity levels. These can be one of low, medium, high, or critical. Refer to the job file documentation for further details on these. This is the JSON report file generated by the TLS emissary for the one and only TLS scanner test session. These are the three ND JSON result files generated by Cucumber for the three test sessions: low-priv user app scanner test session, admin user app scanner test session, and the one and only TLS scanner test session. The app scanner admin user test session for the profile route has completed. It's now starting on the memos route. The app scanner low-priv user test session for the single profile route has finished. The log, which has just scrolled off the screen, provides defect counts and details of where to look in the reports. This is the log and outcomes files documentation. The app scanner admin user test session for the memos route has completed, which means the test session it's in is finished. In this case, both low-priv user and admin user test sessions have failed. The CLI log file that I showed earlier contains details of how to use the report files to locate and remediate the defects. You'll also notice that the stage 2 containers have been brought down, and we've just right arrowed to the TLS tester to watch it finish. The test session for the TLS scanner has now finished. This also failed because the defect count exceeded the alert threshold that the build user defined in the job file. You may also notice that the total tester progress meter hasn't reached 100%. This is because the server scanner isn't currently enabled. As you can see, the outcomes files have been downloaded for you to inspect.
So we're looking for contributors to come and join the OWASP PurpleTeam core team. If you're keen to help us work on PurpleTeam, or if you just want to take it for a spin, you can find us at Twitter at PurpleTeam Labs, and that's the URL there to basically find all the different ways that you can contact us and interact with us. So that's pretty much our PurpleTeam. Do we have any questions?
That was great. Thank you very much, Kim. Certainly comprehensive. So, we saw a complete walkthrough there. Certainly wasn't aware that it was being embraced within the OWASP community. So that certainly is very interesting. In terms of people beginning to participate, is there any kind of core skill set you expect that we should make sure that people are aware of to be a contributor?
Not really. At the moment, I've got a couple of Google Summer of Code students just come on board. One's a little bit more advanced than the other, but neither of them have got any sort of we've got really much in the way of industry skills. They're actually still like university students with basically I mean, they're doing well.
Sure.
Technically, I think they can program in a couple of different languages and that sort of thing, but
Sure.
not a lot more than that. Docker's used quite extensively. Docker Compose is currently. There's nothing really special.
Okay. No, understood. And the fact that you've got the whole framework up there on, transparent on open source, I think it's a great way as well of developers who are maybe new to this area gaining exposure and understanding exactly what's going on. So I'd certainly be encouraging, developers to, who are interested in that whole area. This is probably one of the best toolkits to get involved with in terms of the level of transparency that you're going to meet when you look at the toolkit. Which I think is quite rare. So therefore, a very good framework for learning. There's so much that overlaps with OWASP these days, and this sounds like an extremely useful tool, especially in the SAS configuration, in terms of bringing that to bear. So very interesting.
Cool.
Okay, well, it looks like we don't seem to have any further questions in here, but I know you've got your contact details on the slides and on the overview for the session there, so I'm sure people can get in touch. But otherwise, if there are no further questions, I'll bring this session to a close. Thank you very much again, Kim. That's been a brilliant session. The rest of you on the observability and security track will begin again tomorrow. Don't forget, we've got the keynote coming up at 20 past the hour today. That's across all streams. But otherwise, we'll see you again in the observability and security stream tomorrow. Thank you very much for being with us.
Thanks all.